This relation is a function of x because every number you can think of to plug in for x, it's only going to correspond to one y value. If this is y squared, then you have a problem because if you plug in 1 in for x, then y could either be -1 or +1. That wouldn't be a function. But this is a function of x. So if you're trying to determine whether a function is even, odd, or neither, then you'll want to write out three functions here. The original f of x, so that's just x to the fourth. You'll want to write out f of negative x, which means you go through the function and replace every x with negative x. And then a final one would be negative f of x, which just means you multiply the entire function by -1. Okay, so let's write out what each of these are. F of x, that means it's the original function unchanged. That's x to the fourth. Okay, that's all we have to do there. F of negative x, that means I'm going to replace every x I see in my function with negative x. So this x got replaced with negative x. And if we raise that to the fourth power, the negative sign isn't going to matter. Because if you take any negative number and raise it to an even power, then a negative times a negative is going to make a positive. Negative times a negative is going to make a positive. You're going to get a positive result every time you do that. So this is what f of negative x is, but here is a more simple way of expressing that. Because the negative sign isn't going to matter. And the negative f of x, that means I multiply the entire function by -1, so I get negative x to the fourth. Okay, once you have all three of those, something is even. Yeah, write it down. Even if f of x equals f of negative x. It's odd if f of negative x equals negative f of x. So let's check the even condition. Does this function match this function? It does, right? They're the same, so this is an even function of x. We can check the odd condition too. Does our result for f of negative x equal negative f of x? So does this equal this? No, they're not the exact same thing after simplifying, so it's not odd, okay? If it's even, it can't be odd, okay? If it's odd, it can't be even. And that's it, we're done, okay? That's it for that one. So let's do the same thing for this one. My f of x, I need to write my f of x, I need to write f of negative x, and I need to write negative f of x. So f of x, that's just 1 over x. F of negative x, that means I'm supposed to replace every x I see with negative x. So that's what that looks like. But we usually don't like negatives in the denominator. Look, -1 over x is the same thing as 1 over negative x, right? Because it's going to be a negative result if x is positive, and a positive result if x is negative, either way. And negative f of x means I multiply the entire outside of this thing by -1. Okay? So the even condition, it's even if these two things equal each other. But they're not equal to each other, right? One's 1 over x, the other one's -1 over x. So it's not even. Is it odd? It would be odd if these two things are equal to each other. And they are, right? -1 over x is the same thing as -1 over x. This is an odd function here. Okay. Last one. This is actually really similar to this one up here. The same type of thing is going to happen. F of x is x squared. F of negative x, that's negative x squared. But since you're squaring a negative number, or vice versa, it's always going to be positive, the result here. So we can rewrite that as x squared. And the negative f of x, if I multiply the outside of this function by a negative sign, that's negative x squared. It's even if these two things are equal to each other, and they are, right? So this is even. And then I made one last one, a little bit different. This relation is a function. F of x, the function of x, is x squared plus 1. So to see if it's even, let's figure out what f of negative x is. I'm going to replace x with negative x. Now I can simplify that. Negative x squared is going to be just x squared because the negatives squaring will make them positive. And then negative f of x means I multiply the entire outside by -1. That's going to be negative x squared minus 1. Okay? So these two things are the same, right? So this is another even function. And here, one more. Let's do y equals x minus 1 squared. So my f of x, that's x minus 1 squared. Okay. My f of negative x, that one's a little bit more complicated this time. If I replace x with negative x, I can't use my squaring trick because I have to do a subtract 1 in there. So in order to figure that out, I could expand by multiplying this parentheses times itself. And if you do negative x minus 1 times negative x minus 1, you're going to get x squared plus x, so plus 2x, then plus 1. You expand this, okay? And if you expand this one, because I'm checking to see if they're even, these two things have to be equal. X minus 1 times itself, that's x squared minus 2x plus 1. They're not the same, right? So it's not even. They're not the same. The last thing to check is negative f of x. So if I multiply the entire outside of this of f of x by -1, it looks like this. And then I could expand x minus 1 squared. I just did that over here. That's x squared minus 2x plus 1. And then if I distribute that negative sign, okay, it's even if these two things are equal, but they're not because of that sign in the middle. It's odd if these two things are equal, but they're not because there's two different signs that are not the same. So this one is neither even nor odd.